Step questions can often feel like a completely different language, right? But what if I told you that there's a systematic approach that you can use to get these top marks in these questions? So I'm going to give you a step-by-step guide to approach as soon as you open that paper up to see which questions you want to attempt, which ones you just want to leave. So what we're going to cover today is how to actually approach these step questions in a more strategic and logical way. And I'm going to give you some tips to understand the format and the structure of these questions. And we're going to use some real examples from past paper questions. So step one is scan the questions quickly. So we're going to go through each question in the paper, have a look at what the major topic is of the question, and then have a look in detail at each of the parts of the question. See what topics they also delve into. Because the worst thing you can do is get halfway through a question and realise, oh, this goes into a different topic than I expected, and I'm awful at that topic. Once you've got an idea of the questions you want to attempt, you've hopefully narrowed it down to about 6, and have a look at them each in a bit more detail. So step 2, look at each of the parts of, say, your favourite question, and break it down into manageable chunks. They'll often have parts A, B, and C, but what they don't have is the fact that part A has 3 different questions within it. We want to break that up and break it up into sub-parts so that you know what you're answering. You know what answers to give for each little part of that question. And it breaks it up so we know what we're doing step by step. So step 3, decode the wording. We want to be very clear here in what we're actually doing for the question. Maths is known for having lots of different words that mean different things, such as write down, show that, hence, determine, find the value of. They each mean slightly different things. At the end of the day, it's all just solving the question. But we want to make sure that we're given the answer that the examiner wants to make sure, again, we're getting all of those marks. We don't want to lose marks because we did it 3 lines up and then we just didn't write it down as our final answer. Step 4, understanding where the question is going. This one's a bit trickier because you can't always do it without having already got into the question. But what we can kind of have a look at is seeing where the question is taking us. So how does part A connect to part B, to connect to part C? Are they trying to show us something in part A and then we're going to apply it in part B? But generally what the examiner is trying to do is they're trying to show us something, they're trying to teach us something and see if we can learn from them as they go through the question. Okay, so now let's have a bit of a walkthrough through a step paper from 2020. So this is step 2, and I'm going to walk through what I would actually do if I was starting this paper. So first off, scroll down to the first question. So I'm looking at this question and I'm thinking, it's integration by substitution. It looks like I'm going to have to apply a substitution in the first part, and the second part looks very similar to the first part. I'm going to do another integration by substitution. It looks like I'm going to have to do something similar for part 3. Not super clear yet what I'm going to do, but it looks something similar. So that's integration by substitution, and I can write that down somewhere above. And I'm somewhat good at integration by substitution, so I would generally say that this is one I would go for. So however you want to do it, I might mark it with a tick and say, yeah, I'm happy to do that one. Okay, moving on to question 2. Differential equations. Again, I'm generally pretty good at differential equations, so I'd say this one looks good to me. It looks like I'm going to have to solve a differential equation, get an equation out, and then do some sketches. I'm generally happy with that. I think I'll have a good go at that. And can I solve the differential equation from a first glance? I think I would give that one a good go. And I'd say, yeah, I'm happy with that one. So I'd also do that one. Okay. Question 3. Oh, question 3 is quite a big one. And I'm seeing that at the start, it looks like it's sequences and series. But then when I have a look into it, it looks like it's more like proof. Prove that any sequence of positive real numbers. Bit different from what I was expecting because I don't do many proofs with sequences and series. Again, proof for part 2. So this is more a proof question by the looks of it. I'm not that keen on sequences and series, so I generally put that as an X, and I wouldn't be too happy to do that one. Continuing on, question 4. Let's have a look at this one. Given that A, B, and C have lengths of sides of a triangle, explain why C is less than A plus B. Okay. Doesn't sound too hard, but it's quite conceptual. And I don't know how happy I am with that, so I'd probably, again, say that was a no for me. I'm much more keen on the integration and the differential equations. Okay. Again, looks again to be very similar, sequences and series. We've got a geometric sequence in there. But then again, I'm also again seeing prove that, and then find a value. However, proving that something's non-negative and divisible by 9 generally is not too bad. It's not too difficult to prove. So I'm not super against this one. But then when I start looking towards the end, show that there are no further values of x. Sometimes showing that there's not something is a lot harder than showing one exists. So thinking it might be quite difficult. So maybe I'll put that one as a maybe. So again, it's sequences and series, and it's proof again. Okay, matrices. Generally pretty good with matrices. So I'm pretty happy to have a good attempt at this one. But looking at what I'm actually going to do, prove that doesn't look too difficult in part I. Prove that. It's starting to get a bit more difficult. Doesn't look too bad, but I'm not super keen on it. It's not one I would be jumping at joy for doing. So I'll again put that as a maybe and write matrices at the top so I know what it is. Okay. Complex numbers. What does it ask me to do? Let z be complex number 3 plus ti. Essentially a straight line in the complex plane. Show that that is independent of t. Doesn't sound too bad. Looks like I'm just going to have to do some manipulation of complex numbers. Doesn't look too bad actually. It looks like just a manipulation of the two equations to show that one's a circle and one's a line. I'm looking pretty happy with this one. Part II is just another line that's vertical in the complex plane instead of horizontal. I think that's a tick for me. That'd be my favourite one so far. Okay, question 8. In this question, f of x is a quartic polynomial where the coefficient of x to the 4 is equal to 1, has 4 roots 0, a, b and c. So, not too bad so far. I can kind of have an idea of what the polynomial looks like because I know what all the roots are, so I could write it out as a general equation. Sketch it. Yeah, it looks like just using information about integrals and what the polynomial looks like. Looks like it's going to be a lot of algebra, but I'm fine with a lot of algebra work. So yeah, I would say that again is another tick for me, so that's a lot of algebra. I'd write for that one. And potentially integration, but the integration looks pretty simple. So again, moving on to mechanics. Again, mechanics for me is, I very much like mechanics, so we'll definitely look at mechanics. For me, statistics, I would skip statistics completely. Not a big statistics fan, so I may look at it if I'm desperate for questions, but probably wouldn't go to it. Okay, so now that we've done the first step, we want to go on to step number 2, which is to break it down into more manageable chunks. For this one, I've chose question 7, which was on the complex numbers. And I want to work out how I can break down each of the 2 parts into a more manageable chunks. So, to start off with, let's have a look at part I. So let z be a complex number, 3 plus ti, where t, within the real numbers, then show that the modulus of w minus 1 is independent of t. Okay, so there's the first part for me. So let me make a mark for that. That's essentially the first part of the question. Hence show that if z is a complex number on the line, the real of z is 3 in the diagram diagram, then w lies on a circle in diagram diagram with centre 1. Okay, there's the second part. So already 2 parts within this, and we're not even on to the second paragraph yet. So let v be the line, the real of z equals p, where p is a real constant not equal to 2. So that's not a question, that's just set up. Show that if z lies on v, then w lies on the circle whose centre and radius you should give in terms of p. So again, that's the next part. And I can also note that they want to give the centre and the radius. They then ask, for which z on v is the imaginary greater than 0? So that's the last part. So realistically, within part I, they've already asked me 4 different questions. Okay, so that's part I. Moving on to part II. Well, let h be the line imaginary of z equals q, where q is a non-zero real constant. So again, not a question yet, just a setup. Show that if z lies on h, then w lies on a circle whose centre and radius you should give in terms of q. That's the first question. Looking very familiar to the first part as well. And then for which z on h is the real of w greater than 0? And that's the second question. So we just want to break it down into these manageable chunks where we're answering one question at a time. Generally they ask it in an order where you're moving from one line to the next. So we're going to do the first bit first, then the next bit. You shouldn't be jumping around in the different parts of the question. Okay, so we've done step 1 and step 2. Step 3, breaking down the terminology. Well, they've not actually used too much here. So they've used show that, so that's this one here. which just means that they've told us what the answer is, and we just need to use our logic to get to that answer. Here you've got to be very clear in your writing. You can't just write the answer down because they've given you the answer. You've got to show the steps clearly. The next thing they've said is hence show that. Hence, commonly used in maths, just means use the previous part. If you're not using the previous part, something's probably gone wrong. If it says hence or otherwise, then yeah, you can do it separately, but they've just said hence. We should be using the previous part, and that's how we get our marks. Later on in the question, they use show that again. The only other terminology they use is for which z. All that means is we just need to give a list of z. Here they haven't given us the answer, but we can find the z, and then that should be our final answer. In part B, they use the same terminology, show that and for which z. But those are the key bits we want to be looking at as to what our answers should be. Okay, so the final part of looking at these questions is understanding where the question's going. What they're going to get me to do in the first bit is they're asking me to look at a line which is 3 plus ti, which is essentially a line in the complex plane where the real part is 3 and the imaginary part is plus ti. So it's essentially a vertical line going to the complex plane. That's equivalent to this line that they've said later. Real of z equals 3. It's the same thing, just two different ways of writing it. But what they do later in the second paragraph is they say the real of z equals p. So my thought process is going, well, there's not that much difference from what they've done. They've just given me a very specific example. They've given me 3 here, but now p could be any constant. So all I need to do is, instead of using that 3 plus ti, I use p plus ti. And that's the exact same problem. I'll follow the same methodology and I should come to a different answer, but the format of my solution should be exactly the same. And then you can see when we go on to part 2 that when they talk about the imaginary of z equals q, realistically not much has changed. All they've done is, instead of doing a vertical line with a constant real part, we've now got a horizontal line with a constant imaginary part, which is q. So instead of it being 3 plus ti, it will maybe be t plus qi, where q is a constant. And then all we're going to do is follow the exact same process again. That's what they're doing in this question. And that's generally how you should approach these questions. You've not learnt much from that. It's just a glimpse into what the question would be. And you can do this process in your head very quickly as you're starting the question. If you can't often see that in these questions, maybe it's not the perfect question for you. Maybe you should have a look at one of the other ones first and then come back to this. It's not always doable, but if you can do that, generally it's a good start and it means that you can quickly progress through the question. It's going to be a good question for you if you can see that already. So just to quickly summarise, start off by having a quick read through all the questions, see which ones are good for you, break them down into manageable chunks and see what you can do for each of those chunks. Go through the terminology, make sure you're happy with it all, and then finally understanding where the question's going. If you can do that before you've even started, you'll be in a good place to actually have a good go at the question. I hope you found this video helpful. If you've got any really difficult step questions that you'd like some help with, please send them over and I'll cover them in a future video. Please consider subscribing for more tips and tricks on how to really improve in step. And remember, every difficult step problem you attempt gets you closer to mastering step and to really improving as a mathematician. But thank you very much, and I'll see you in the next one.